The word reflecting sums up so much of the process involved in solving a mathematical problem, or even thinking about it. Now, this is part and parcel of the mathematical process expectations of the curriculum because it is so important. Let's see what the curriculum says about this. Students will demonstrate that they are reflecting on and monitoring their thinking to help clarify their understanding as they complete an investigation or solve a problem. Long sentence, lot of words. What does it mean? Students need to be reflecting on the techniques that they are going to use, or more importantly, that they have used or have proposed to use to solve a problem. They need to monitor their thinking to help clarify their understanding as they complete an investigation or solve a problem. In other words, how do students think when they start with a problem? What do they think about would be the next step? What do they think about would be the end? All those thought processes should be monitored by the students themselves. They should be analytical and critical about themselves. They should reflect on this process, whether it was a success or not. Maybe it was a success, but you could have been more effective, because that's also something that needs to be taken into account. Assessing the effectiveness of a technique. If you take 10 lines to complete something that could have been done in 3, is it effective? More often than not, it will not be. But then again, your strategy and the process that you use might take 10 lines, but it's a foolproof result. You can justify the longer technique by claiming to be more effective and accurate in the final answer. Students should also be proposing alternative approaches to solving problems. For instance, if we say this equation, x plus 2 is equal to 4, since we are currently looking at linear equations, we can then follow the traditional approach by saying minus 2 there so that the 2's fall away, which means we must also minus 2 on the right hand side, giving us an answer of x equals to 2. But another student might come and say, if that is the equation, x plus 2 is equal to 4, I will ask one question. What plus 2 is equal to 4? Oh, of course, 2 plus 2 is equal to 4. So in the place of x, there should have been a 2. Both of these yield exactly the same result. There's not a wrong and a right with these two techniques. It's purely a scenario of one working better at times than the other. That's all. So the alternative approach that the student may have proposed or may have even followed is not wrong. And that's very important. But reflecting on the effectiveness and the accuracy in the long run is part and parcel of having the ability to choose more than one strategy. And then judging the reasonableness of results by verifying solutions. What does that mean? Well, in a nutshell, take that answer and substitute it back and see if you actually get 4 on both sides. Because if you do substitute the x with 2, you'll get 2 plus 2 on the left hand side, and the right hand side originally was 4, so you'll get 4 is equal to 4. That is verifying the solution, making sure that the solution is not just guesswork, but is pretty accurate because it was tested. Very, very important. That's probably one of the most important reflecting points made here, is that an answer should never be assumed to be correct. You should know it is correct, and if you need to test and verify the solution, do that.